Today I'm just going to speak about Vaadin, give a little intro for it, and speak a bit more generally about rich web applications. If you want to give any feedback, there is my Twitter account. So, how many of you have used Vaadin? No one. Strange. So it seems that I've mostly been speaking at Europe and on the West Coast, and in the East Coast it seems that no one knows about Vaadin. Okay, we're going to change that. So Vaadin, it's actually a Finnish word. Team is based in Finland, and it means reindeer, or more specifically female reindeer. So if you look at the logo this way, it's kind of nose and the horns of the reindeer. But actually, to define the framework, it's a framework for building rich web applications, and it's mostly focused on business applications and enterprise applications, kind of applications that you are using for the whole day. You're using with keyboard that could replace all those old Swing and Visual Basic and what have you applications, but still runs on web and still is programmed in Java. So we kind of think that we are abstracting away from HTML. So if you are a JavaScript guy, you are probably on the wrong session, but if you hate JavaScript, this is definitely the correct tool for you. So we are kind of putting Java or Scala or what have you on top of HTML and enabling you to create application fully on that language. A bit of history behind Vaadin. This is actually quite old project that already got started in '98 when I was leading a virtual hospital project where we built kind of hospital communication systems with Perl and what have scripting techniques we have back in the days. And the team looked like this. And the trouble was that we had a lot of different browsers, a lot of different kind of compatibility issues between the browsers. We had large code base of Perl, and it became kind of a mess. And we thought maybe we should do something about it and create a new kind of tool for building web applications. So we kind of started copying. We copied object-oriented design, we copied from Java, we copied from the desktop paradigm, and kind of moved the desktop paradigm to the web. And that was back in '98. So we thought that, hey, this is a good idea, start a company around it, publish it as an open source project in 2002, and it didn't take off too well. We added Ajax, we added Google Web Toolkit, but only about 2009, when we rebranded the whole thing and added some features and nicer looking components, it kind of started to take off. So at the moment we are seeing something like 50,000 active developers using Vaadin around the world. It's mostly used in enterprises for building intranet applications, building kind of business applications where you have a lot of data and you have a long maintenance period for the application, and you must kind of do different kind of integrations. There is a really active community around it. It has created around 200 add-on components for Vaadin, posting around 1,500 posts a month, and it's backed by a 50-person company. So this is kind of totally open source effort. And everything that we are doing and how we are making decisions is openly visible on vaadin.com, so if you want to see where Vaadin is going next, just take a look at the roadmap. But today I'm more giving a kind of introduction to Vaadin. Whenever you hear somebody pitching a technology that they are somehow involved in, you must ask why this guy is here and what he's trying to sell to you. In this case, it's actually truly open. Vaadin is Apache license, so you can use it for anything you want to. It doesn't cost anything. There are no hooks built in. We actually live out of services and support and some add-on tooling on top of Vaadin. But we have been really strict in keeping Vaadin fully free for any kind of use. So, what we're going to speak about. First, a bit of server-side RIA in general, pros and cons, and what is it all about. Then live coding. I'm going to code one application from scratch to kind of show how it looks like to code with Vaadin, and then kind of deep dive how it's actually working under the hood. I hope you have a lot of questions in the end. Or if you have any questions in the meantime, just ask. rich internet applications. Let's start from kind of the traditional model. Everybody knows how Web 1.0 works. You basically have a web browser right here. You have a kind of MVC model on the server side. It fetches pages from the server and gets back page and sends parameters and again. So it's like really simple and proven model. Then came along like I like to call them fat clients, kind of rich client-side applications, where you move basically control the view to the client side, and with that you get much more interactive applications. So basically a lot of things can happen right here, and you can go back to the server side and fetch some JSON and then modify something on the screen. And this is actually a really good model. I think the best framework around this model is at the moment Apache Play framework, and of course many frameworks on the client side for building with all the interaction on the client side in JavaScript. But the challenge here is that while it's quite easy to hack together a web page and put some jQuery on top of that, it's actually not too easy to build larger applications in JavaScript. So if you think about it, it's mostly around weak typing and the troubles related to weak typing. So you kind of lose like really robust code completion if you have weak typing. Refactoring is not that easy anymore, and when refactoring is not easy and your project gets big, it's always tends to get also messy when you cannot just easily change things and namings. Compile time checking is missing, and then you might end up having or finding the troubles on the runtime, and that's actually quite challenging. And one of the things that is quite often missing from project is good documented APIs. And with static typing you get at least some basic APIs with Java docs generated, but if you don't have any static typing, then it might be that you have nothing to begin with. So it might be totally good if you have just one developer or two developers, but if you have more and you also start to have some kind of code base, it kind of in many cases becomes a mess, at least over time, when the team changes and people are maintain the code base. And I think this is kind of the most challenging part of the kind of client-side RIA development at the moment. Another part is browsers, that they are still different. Back in '98 they were really different. Nowadays they are still quite different. So you have different kind of bugs in browsers. Different browsers have different bugs, and then when you start working around those bugs, you might break something else in your application. Speed is different. This one is IE7, and that's Chrome, then it's a bit faster. And when you're kind of targeting different kind of browser at the same time, you either are choosing to utilize all the power in fast browsers and then breaking slower ones, or it's just kind of underutilizing all the browsers. And different kind of features in different browsers. And these are changing all the time. For example, in latest iOS release, they lost SQL-based local storage for certain applications. And this is kind of big thing when you kind of have been building your application on top of certain feature and then you just happen to lose it in one browser. It kind of makes you rewrite a lot of code. There is actually a really nice solution for that from Google Web Toolkit. How many of you have been using Google Web Toolkit? Just a couple of persons. This is actually a really nice project. What it's basically doing is taking your application UI written in Java together with some kind of widgets provided by Google or Shensa or what have you, widget provider, and then some core Java classes. Compiles them together and spits out JavaScript. And it basically spits out one version for each browser that it supports. So it kind of works around the browser bugs and browser differences quite well for you automatically. So basically you can get to write the whole application in 100% Java. You get all the benefits of Java, like object-oriented design and static typing and really good tooling. Also you end up having less bugs. So you probably end up using much less time debugging those browser differences and just working out why this browser doesn't work correctly, and when you fix that, another browser kind of breaks up. It's on the client side. This is both good side and a challenging side. So everything happens on the client side, but it also implies that every piece of data that you are using must be fetched asynchronously from the server side. So you must build quite a lot of services on the server side and open up those to the web and control these services and the security of those services. There is a third way of writing application, and that's thin clients. So in a way, it just keeps MVC on the server side, has some kind of way of reflecting the UI state to the client side, and then passing all the events back to the server side. Looks complicated, but the good thing that all the server-side RIA frameworks are handling this part automatically. So you don't have to do any design for communications or rendering at all. You just code on the server side, and it kind of keeps your coding model much, much simpler. So basically, kind of get the same benefits as from Google Web Toolkit. It's simpler and less bugs with the strong programming language. But at the same time, you kind of get more trusted and well-defined environment. You're running on the server side, and you know the server, the application you're running on. So you actually can trust the runtime in a way that if you know that it happens to have like 16 gigs of memory, it has 16 gigs of memory. You know that no one is kind of changing that runtime on the fly. So for example, when you're writing JavaScript, you don't know if somebody just makes a little change in your code and then the application does something else. It's totally kind of, it's not anyhow limited by the browser model. In browser model, you have to take care of that no one is exploiting any security troubles in browser, for example, and you have kind of limited model where you can run parallel threads or anything like that. On the server side, you can do whatever you want to do. Just do it. And I think the biggest thing is that you have access directly to all the libraries on the server side. You can use any language you want to. So if you want to write your code in Java, do that. If you want to use Groovy or Scala or what have you, then just choose that language. And whatever language will work for you. More importantly, it's much, much simplified. So you don't have to do RPC layer yourself. There are no services to write because you're running on the server side. All the calls to the backend are synchronous, so you don't have to do those callbacks and then wait for data to appear on those callbacks. You just create a synchronous call to whatever backend you have. And you have direct access to any kind of APIs you have on the server side, whether those be like Spring APIs or your own custom libraries. It's quite a bit more secure model. All the code stays on the server side and nobody can read it. So it's kind of black box model when you're comparing to the white box model of the JavaScript, where everybody can read your UI code and make changes there. You also end up opening much, much less services openly to web. So you kind of have less holes and less kind of attack surface to protect. And the runtime is predictable. On the downside, it's not as scalable. So your user interface state is stored on the server's memory, so it certainly consumes that memory, and it eats more CPU as more of the processing is done on the server side. In practice, this might not be a problem for an enterprise application. So, for example, for a ticketing application, we measured to have 12,000 concurrent users per front-end server. So, with just one server, you could run quite large enterprise application. For a front-facing application where you're expecting to have millions of users, this might not be enough. So, for that kind of applications, you probably should be doing client-side RIA. But I think for the most enterprise applications, just add a couple of front-end servers and you are good to go. One strict restriction is that there is no offline mode. So if you want to build offline applications for mobile, then server-side RIA is not for you. Good side is that you can augment server-side RIA applications with client-side RIA. So you could just add a couple of features that could be used offline also from the server-side RIA application. but if you end up like moving all the features, or you end up having requirements for all the features being also supported on offline, you probably should be writing client-side RIA applications in the first place. But I think that the kind of number one benefit is that it's much faster to write server-side RIA applications. So if I would be reaching that it's so much faster than client-side RIA, I think you wouldn't be believing me. So it's much nicer to just try it out. So we'll write a simple application. This is a document managing application that just lists a bunch of Javadoc files on a table. It has some layout, basically a split panel here, and then you can edit those documents in a Vysiwyg editor. So you have one extra window here, and you could edit this visually or in HTML. So we're going to build this kind of application and see how it goes. So let's try that out. To build a project, you could just choose to use Vaadin project in Eclipse. That is just a lot of echo. This is actually just a normal web project. So you could actually use any web project and just add Vaadin library to that project. So just create the project and let's call that DM. And we want to use, let's see, Java 6, deploy as a servlet, and let's use Vaadin 6. And create this one. So what we have here is a trivial application where we have, on the web content side, we have Vaadin library, and then we have one web XML file. If you are using new Java EE, then you don't have to have any web XML, but this is just defining one servlet. So basically running application servlet whenever you go to the root URL. This is automatically generated and you don't have to touch that one. Basically it just says that we want to run this application that we will be writing here. Aside from that, we just have one Java file. Like this. So it's just a hello world file, a hello world application here. Basically we open up a window. This is our main browser window. We add a hello world there. As a label, and that's it. Thing to note is that we don't have any HTML templates, we don't have any JavaScript files here. So let's run that one. I'm using JRebel for editing, it kind of makes round trip a bit quicker. By the way, how many of you are using JRebel? Just one. It's a really cool product, take a look at that. So let's run this one. So basically saying just hello world. I'll open that in a real browser. So let's see. First of all, when I'm making changes here, just save those changes and reload the page. What happens? Nothing. And the reason for that is that this is actually a stateful application. So the state starts when the user goes to the application first time, basically opens the web page. And then we run this init method, and that's it. It stays on the same state as long as the user is using the application, as long as the session is still valid. So we'll say that we want to explicitly reload this application. Like this. And now we can just edit it, save, and see the results immediately. But let's start writing the real application. So first of all, we need some kind of data source. I'm just using a trivial data source here for demo purposes. I just happen to have a bunch of HTML files on my desktop. So we just show these ones on the web. On a real application, you would be using like JPA or I don't know what kind of backend you have, but here we are good with just files. So let's make a data source for that. File system container called docs. And point that to my desktop. Like this. Okay, now we have a data source here. Then create some UI component to show those. So just use a combo box to keep this one simple. So let's call that the selector. Like this, and then we could just connect this selector to that data source. So let's say choose a doc like this, and put that one on the screen like this. We just add that to the window, and let's see how it goes. So now we have a combo box. It goes through the different files on my desktop. We have things like autocomplete here, and paging and so forth automatically. So let's show the document on screen also. So just add a label here. Call it the doc. And it should be in HTML mode. Like that. So what we want to do, of course, add that to screen, is to listen to changes from the selector. So we just say add a listener for selector, and whenever we are getting a value change event, we should be changing the label contents. So let's see. Our label is called doc, and we set a data source for it. And the data source could be just a text file. So let's create the text file here. And the text file, we get that from the selector. So we get selector get the value. This is just a file typed object like this. So it almost works, but this is still running on a web browser. It's still running on top of JavaScript and Ajax. So we should instruct Vaadin to send those events immediately back to us on the server side. So let's say cell set immediate true. So this basically implements Ajax on one line of code. Whenever we are now choosing a document here, it automatically runs this code on our listening code and just changes the contents of the label. And we could actually put the breakpoint there and it just works. So this doesn't look at all like our application that we were supposed to write. So let's add some layouting here. First of all, we had this split panel. So let's create a new split panel. Like this. Oops, did I create the wrong typed split panel? Yeah. We want the Vaadin split panel, not JWT split panel. So now we have split panel here, and we have this combo box on the upper right corner, and the lower part works as it should be working. One of the nice things in Vaadin is that we are sharing interfaces between the components that handle similar kind of data. So for example, here we could just change this combo box to a table, just like this. So now we have a table here, and it lists some columns. These are basically gotten from the data source, so kind of icon and size and so forth. Unfortunately, we cannot select anything, so we just ask table to be selectable. It's not selectable by default, like this. And now we can just choose the documents here and show them on the screen. The layout is still a bit cumbersome, so let's ask Vaadin to connect this split panel here to the table. So we could just say, let's see, set size full. So basically meaning that please use all the space in the container. So now we are kind of automatically scaling the table while we are changing the size of the browser. So first part of the application is done. Who is following still? Everybody? Oh, yeah. Okay, so we wanted to add a visual editor here, and let's create that as a new component. This is something quite typical in Vaadin application. Every part of the UI is created as a component. So let's create a new component as a composite and call that the editor. So our editor component just has a build layout method that does nothing. Basically just sets a layout here. We could build the component by editing this file, but we could also use design mode for editing this Java file. So basically we could just choose, let's put tab sheet here, like this. So that's the tab sheet, even though it doesn't look like much. Add restrict array inside of the tab sheet, like this. Actually, we could make this a bit larger. Wider and fill in the whole space. And then we also had this text area for editing as an HTML. Let's drag that one also here. And let's make this also occupy whole screen. And then we could just edit some properties. Let's say this is a HTML and the name of the property is text, no, HTML. And this one should be RTA. And maybe like document. And while we were editing this visually, we actually were editing the Java source code at the same time. And we can actually edit this Java source code and go back and forth between the visual editor and the Java source code version. But this is actually already done, so we'll just edit the constructor to point this one to our data source. So let's use property typed data source doc here and connect that one to our editors. So we had, let's see, HTML editor, connect that to our document. Same goes for the RTA. And then we want these ones to immediately send all the changes back to the server side. So we say HTML set immediate true. And same goes for the RTA. So now our component is ready and we can start using it in our application. So let's see, our application looks like this and we should be adding some kind of edit button here. I'll just refactor a bit. So we'll make this one build layout and this part should be like wire up. And for the layout, we could actually wrap the whole layout in a absolute layout, meaning that we could position pixel by pixel. So let's see. Like this. And then just put the split panel inside the absolute layout. Like this. Actually, we haven't made any changes to layout yet. I'm just refactoring my code to make it a bit more sane. So it should still look like it looks now. Yes. So then just create a new button and put that on the screen. So where we should put the button? Let's create the button. Like this. Let's call it edit and just put that on the screen. So like this. So it ends up being here, but we want to reposition it. So let's say it should be bottom 10 pixels and right 10 pixels, like this. And then add a listener for the button to actually edit something. So let's see. Edit button, add a listener. So this program model is quite similar to Swing, but you're actually running everything on the server side, so you have access to all the backend resources like we are accessing files right here. New click listener, and when the button is clicked, what should we do? We should create a new window, dialog, and just add this one to the main window. Like this. Let's see if it works. So now we can create new windows here. So let's, instead of creating new empty windows, we could connect these to our editor component. So we open this editor component, or create a new one, and then point this to the dock. And actually, we don't even have to refresh the page. We could just create new editors. But let's select the combo. I refresh. No. Yeah, I refresh. It's so messy. So let's select the file here and start editing it. We have file right here. And when we are changing this like this, we actually also reflect all the changes to all the users of the same data source. So basically, this gets saved to the file and gets updated in different parts of the application that is using the same data source. We could also edit that as an HTML here, if we can find it. I can't find it. Here it is. This is a good case study why you don't want to do UIs in XML or completely HTML. So it should be editing the same file here. So that's it. I think it was something like 15 minutes or so. Who thinks this is complicated? Who thinks it is simple? Okay. So this is basically just around 50 lines of code. And we don't have any JavaScripts. We did this from scratch in 15 minutes. So actually, if you start thinking of this model and thinking of a bit larger enterprise application, it becomes obvious that this is quite efficient way of building larger applications or UIs for larger applications. So how does it work actually? We have 3 goals in Vaadin: developer experience, user experience, and scalability. And the important thing to understand here is that these are in order. So this one is the most important one for us. So if we really have to do some sacrifices or some compromise in scalability, we do those compromises in order to get better developer experience. And same goes for the user experience. So if user experience could be made better by sacrificing scalability, we do so. But this is still our goal, or one of our goals. And it's, I think, important to understand that different frameworks have different kind of goals. So you might find frameworks where scalability is the most important goal and it scales better than Vaadin, but it might be sacrificing these other goals in order to be able to scale that a bit better. So to create those, or to reach those goals, we basically are leaning on or building on top of 3 different ideas. First one is components. we have large set of components, and there are basically three kinds of components: UI components, data source components, and themes. So let's take a look at UI components. Actually, we could see a live demo for that. This is a sampler application. It basically lists the components in the core Vaadin framework, and you could just go component by component, take a look at some component and see how it looks like, then view source code for it and kind of see how this demo has been implemented, and have links to the documentation and so forth. Basically just kind of see if something you're looking for is in the core Vaadin. Let's see, date. There are also components for building mobile applications called Vaadin TouchKit component set. So these look and feel like native UI components for iPad and iPhone. Android is also supported, but there is no like special Android theme. So, for example, here this is a kind of mock-up application of mail. Everything here is written in Java, runs on the server side, so you could access all the mail folders directly through server-side APIs. The same application also runs on iPad. It just lays out a bit differently. And actually, because this is running on the server side, you could use other languages too for writing this application, like writing this one in Scala. So themes. In Vaadin core package, it comes with 3 different themes: Reindeer, Runo, Chameleon, and then you can create custom themes. So Reindeer theme is this default theme that is mostly kind of geared for enterprise applications. A bit boring theme that goes well with banking application and insurance and such fields. If you want to do something more cool, you could use Runo theme. It's more kind of round and more Web 2.0 type of theme. Or you could use Chameleon if you want to kind of easily customize your look and feel. So just take some component and then pick some colors that you want to use in the theme. Not this one. And kind of basically put your company colors here and then download this theme as a jar package and then add on top of the theme your own things. You can also build fully customized themes, so basically just change the look and feel of all the components. This one is based on Reindeer theme, but it just has a bit different kind of CSS. Let's see. The third thing is data source components. The data model in Vaadin is quite simple. We basically have properties, items, and containers. And this basically means that this is like single thing. This is a backup properties, kind of named properties, and this is like set of these items. So this one could be an object, and this one could be a, let's say, tree of different items. And there are some extra interfaces that extend this container to make it a bit more flexible. But basically these are just 3 simple interfaces that you can implement and glue to any UI component. Or actually, all the UI components support both like external data sources, implementing these interfaces, or putting the data inside the component. So you just can set the value in the text field or bind the text field to an external, let's say, document. There are a bunch of implementations for these. So all the kind of basic or most common data sources are there, so you could just use those or build your own data sources. Second idea, we actually are combining server-side RIA model with Google Web Toolkit. So this means that you basically get the benefits of a Google Web Toolkit programming model as well as server-side RIA programming model at the same time. So if you think of abstraction layers in typical rich web application, you have browser, you have some kind of communication layer, front-end server, and the back-end server. And these can be built with different kind of languages. On the server side, you can use any server-side language. On the client side, it's typically JavaScript or something that compiles to JavaScript. Google Web Toolkit kind of adds one more layer, compiling from Java to JavaScript. So if you look at the Vaadin in this picture, you basically have to implement these two layers here. You have to implement the front-end server layer, you have to implement the back-end server layer. But the important part is that you don't have to implement these layers at all. You can, if you really want to, kind of customize any of these layers, but you only have to implement these two layers. If you're comparing that to Google Web Toolkit, there you have to implement also these two layers somehow. There are really good helpers for helping to build these layers, but you have all these 4 layers in your application. You can also code in JavaScript if you want to, but it's not necessary. In XJS, that I think is at the moment the best kind of JavaScript-oriented rich library, you also have all these 4 layers, but you don't have the Java layer. Instead, you are building the UIs in JavaScript. And I think this picture kind of summarizes the difference between server-side RIA model and the client-side RIA model. You basically can skip a couple of layers in your application. And because you can skip those layers, you have less code to maintain and to write. So how does it actually work? If you write a simple application, just put a text field and a button on the screen and one listening code here. This runs on the server side. So what happens when you're opening a web browser and pointing that to your application? You're actually loading an HTML page, CSS, images, and JavaScript. But these come with the Vaadin framework, so you don't have to write any of these. And you end up loading quite a lot of stuff from the server side. Good side is that this gets compressed to maybe 250K, and if you don't use all the widgets in Vaadin, you can go down to maybe 150K or so. One difference here between server-side RIA and client-side RIA is that this is all you have to load from the server side. Even if your application gets like really, really huge, you have like thousands of views, all of those views are sitting on the server side. You are still loading this around 200K of stuff from the server side, because those views are not loaded to the server side until they are used. So then your UI gets drawn here, and when you start interacting, writing something here and clicking the button, you're actually sending just 2 things on the server side. Basically, we are saying that we changed the contents of this field to Joonas and click this button. And this is altogether around 150 bytes, so it's like really, really small message going to the server side. It goes to your button click handler here, and when you say show notification, you basically leave the control to Vaadin framework for kind of showing that notification. So Vaadin figures out which part of the screen has changed and sends back a notification, or basically this is a small snippet of JSON that says that show a notification here on the screen. And altogether this communication is something like 500 bytes. So it's like one package going into each direction. It's quite efficient. Under the hood, this is implemented in such a way that all of the components have 2 parts. We were using these parts in the demo. So basically, these are just plain old Java objects on the server side, buttons, trees, and so forth. And they have the Java API that you can use. But for each of these, we have a corresponding widget on the client side. And these widgets just kind of are responsible for rendering these components and sending back user-originated events back to the server side. This one is normal Java on the server side. This one is also Java, but it gets compiled with Google Web Toolkit to JavaScript. Good side is that most of the time you are just seeing this server-side part, and the client-side part is kind of hidden from the developers. But the because it is there, it kind of makes adding new components to the framework quite easy. So basically, in order to create a new component, what you do, I mean a new client-side component, we just open up a wizard for that. It creates two Java classes for you. For the server-side part, you define the API that you want to expose to your developers. For the client-side part, you implement rendering, or actually you could use any existing Google Web Toolkit widget, just extend that and add this communication part here on the client-side widget. So when you have implemented this widget, you just package that and using packaging wizard, and I think the important part here is that you put both the client side and the server side and the communications in one package. You basically end up having a jar file that you can distribute to the rest of the team, or you could upload that to Vaadin, basically choosing that, hey, this is a UI component, clicking upload, and it goes to Vaadin directory. That's a kind of collection of those components. And then other persons could use your new component. Or you could kind of search if there is a nice component to use. So for example, let's take a paper stack component. I think this is kind of a good example why you shouldn't be pushing all the components to framework core. It's a nice component, but it's totally useless. So it kind of lays out your components on top of each other, kind of exposing part of the component, like a kind of post-it notes. You can see code examples here. You can download the component, or you could just cut and paste POM to your Maven definitions and get kind of integrated automatically to your project. Or if you just download it and drop that into your project in the basically lib directory, your Eclipse asks, hey, should I kind of integrate this with the widget set in your Vaadin framework automatically? And if you say yes, it uses Google Web Toolkit to compile this widget as a part of the rest of the Vaadin framework. Then you just implement the application. This is just a simple example. We just add a couple of nodes on the screen. I'm not going through these, but basically this is the whole application. There are nothing aside from this code. And it looks like this. So these are labels, normal labels. This is the paper stack component, and you can put like rich components also here. But the important part here is that in order to kind of build this kind of UI component, you have to do quite a bit of browser magic in order to do that. For example, here, as you probably noticed, we are kind of cutting diagonally through the components and showing two components at the same time. So it uses tricks like duplicating DOM multiple times. It calculates the shadows quite complicatedly, uses canvas for drawing the shadows and doing that kind of stuff. But it's fully under the hood. For the user of the component, it just sees one jar file and simple Java API, and all of the rest of that kind of client-side coding is well packaged and kind of hidden. Third idea. Embracing Java. For us, this means that we are trying to be as good Java citizen as possible. Vaadin is actually just one jar file, so it integrates with any kind of environment. You can use any language. For example, here is Vaadin application written in Scala. You can use all the Scala features out there. There is actually an add-on for Vaadin called Scalability that adds Scala APIs on top of Vaadin. And the code is quite a bit more compact than Java, as you can guess. Or you could use Groovy or what have you. We support most of the browsers out there, both mobile and desktop. We even support like really old ones. And this is actually quite painful, but because it's done by Vaadin framework, you don't have to take care of yourself for supporting IE6. We are dropping support for IE6 and IE7 in the next release of Vaadin in order to get some of that pain alleviated and kind of exposed some of the newer features to Vaadin. There are no browser plugins to install. and actually there's nothing to install, so you get kind of web deployment model together with the desktop type program model. You can basically deploy on any server that runs Java servlets or Java portlets, or most cloud offerings. We support Google Web Toolkit directly. Amazon Cloud, of course, works perfectly as it's just any kind of server you deploy there. You can run on Heroku with some trickery. This is a bit more comprehensive list of servers that we test all the releases on, but basically it includes all the different implementations of Servlet API 2.3, basically a really, really old version of Servlet APIs. Because this is just plain Java, there is a good support for tooling. You already saw that Eclipse plugin. There is also IDEA plugin, NetBeans plugin, Maven support, Spring Rule plugin. So, for example, this is a screenshot of the IDEA plugin. It has the same specific editor built in. NetBeans plugin is a bit simpler. So, with NetBeans, I would recommend to use maybe Maven support from NetBeans to build applications, and you don't have this specific editor built in. For Maven, basically just choose a Vaadin archetype and it creates a project for you, or you could build add-on components from Vaadin archetypes, or there are, I think, 7 different archetypes to choose from. So to get started, first of all, go to vaadin.com. You can download Vaadin from there. It's free Apache license, so there is no kind of nothing to buy. If you want to compare it to some other frameworks, there is quite extensive comparison matrix where you can choose the framework you know already and see how these compare and what are the kind of differences between the frameworks. There is a free book about Vaadin. This is 700-page manual of Vaadin, so it kind of introduces all the different features in Vaadin. You could download it as a PDF, or actually you can buy a hard copy from Lulu if you prefer a proper book. There is also some other books, and then there is a really, really nice DSON ref card. I don't know, how many of you have been using DSON ref cards? Just a couple. Take a look at DSON. It's really nice resource where they have like 100 different or over 100 different ref cards that summarize different technologies in 6 or 7 pages. So you get kind of brief overviews on different technologies. There is actually 2 ref cards about Vaadin. First, as a kind of general introduction that has like extended diagram of different components and how they relate to each other. And there is also another one that speaks how LiveRay and Vaadin could be used together. Actually, LiveRay comes with Vaadin, and the tooling in LiveRay includes wizard for building Vaadin-based portlets. But there is a ref card about different kind of considerations when you're using Vaadin and LiveRay together. So, any questions about Vaadin or anything? Yep.
So I looked briefly into Wicket as a web framework alternative, and I found that pretty quickly it kind of devolves into creating extending the components and overriding methods just inline, and you kind of do that all over the place. Is that does that sort of thing happen with Vaadin?
They share some similarities. So both are component models, both are server-side, both are Java-oriented. That's the similar part. The difference is that Wicket is really page-oriented. So it's for building web pages, and you define page flows, you write HTML templates, you hook those HTML templates to Java. And that might be good for purposes where you're building like website. But it's quite different for building an application. Vaadin is really kind of, I would say, application-oriented. You don't have page flows, you don't have page in Vaadin at all. Everything happens within a single page, everything happens as an Ajax automatically. So I would take a look of Wicket, or maybe preferably Play at the moment if you are building a website and you want to use Java on the back end. But if you are building an application that kind of behaves more like single page application, then Vaadin might be more correct choice.
So the question I have is, so this is very developer friendly, which is awesome. Right? But a lot of times when you develop applications, you're working with designers, and so they would give you a design or even some kind of HTML with some CSS.
Yeah.
What are your recommendations for how to sort of combine the design and workflow with this, which seems like, because you're creating the component, you sort of have to recreate the HTML that they might have created?
There is no kind of general recommendations that always do this. In Vaadin, you have a bunch of different layouting models. We were using programmatic layouts here, but you could also use HTML templates if you want to. You could use CSS for layouting. You could use pixel by pixel layout and draw those layouts. So if you're working with designers, either you're getting mockups from there and implementing those mockups by yourself. It might be okay for kind of complicated cases where you have like a lot of technical stuff related to DOM and CSS. But for simple cases, you could just ask them to submit a HTML template for you and use that as a component in Vaadin. Or you could build the application first and then give that back to the designers and ask them to edit the CSS. So there are different modes.
And the second question, what's the server footprint? Like, I guess one big concern is that in order for this single page model to work, you need to sort of keep a fair amount of state for each user. Is A, what's the typical server footprint, and B, is there a way, so yes, it's a single page app and maybe you have many different components that are interacting, but at the same time not all of those components are always being displayed to the user. So like sort of are there some general recommendations about making sure that the server footprint doesn't get crazy?
First to the question, how much is it? It fully depends on the application. Basically everything that you put into application is stored in memory. So if you store like thousands and thousands and thousands of UI components there, it gets big. Typically from a kind of really, really small application, like type of Hello World application, it would be like 10Ks or something like that. For a large enterprise application that is well written, so you don't have like any memory leaks, it might be like 1 meg or something like that, and everything in between those. So that comes to the next question, how you make sure that there are no memory leaks. There is no kind of magic bullet for that. You just have to remember that everything you put in the user session actually is there. So memory profiling is sometimes useful just to see that you are not kind of leaving things around. Sharing data sources between different users might be a good practice if you have like huge in-memory data sources.
And what about things like, another concern I have is synchronization with a database, right? So let's say I have 2 users that are looking at a list of the same object, and one of them changes one of the elements of the list. Sort of how does that work in terms of updating data users thing? Like with the traditional request model, you make a request, you will require the database, and so everybody's up to date.
Yep.
Are there some kind of primitives here as well?
In Vaadin, everything for one application is synchronized. So within one application, you don't have to think about synchronization at all. But if you are sharing something between 2 different application instances, you have like user A and user B, and these are both using the same list in the backend. This list must be synchronized. So this is a way of keeping or kind of preventing any troubles for changing the list from 2 different by 2 different threads at the same time. Or did you?
This is a normal case, right? I have looking at a list of books.
Yep.
And 2 users are looking at the list, and then one of them changes the list. you know, but that the other person is still interacting with the one-page application. Like, is there some kind of automatic like callbacks or updates?
Yes. Yeah, basically all of the data model objects, properties, items, and containers, they all have listeners for updates. So if you are binding, let's say, for example, in this case, when we, where do we have it? So when we were editing this document here, this same data source is now bind already to two different components. This one in the bottom, and as well as this rich UI editor, and actually also this text editor. And when I'm changing the data in one, all of the other components get notified automatically. So basically they register listeners for those data sources when you are connecting them to data sources.
And this listener works across user sessions?
Also, yes. These are just plain Java objects on the server side, so there is nothing magical there.
I understand, but I would imagine that each user gets its own like list of books or whatever, and so you would need to have some kind of like constant polling of the database to see if the database changed.
No. In most cases, you are keeping separate data sources per each user, and then you are sharing some common data on the back end. For example, one of the web shops that were using Vaadin that I saw was using, I think, 100 meg in-memory Lucene container that was shared by all the users, and then each of the users just had like really thin wrapper called Lucene container that was accessing the Lucene database in memory. And in those cases, I don't remember how they implemented the changes to the database. There probably was some kind of update all users when you are changing the product information in the database. But then you are handling it by yourself, and then just those containers say back to the UI components that, hey, now the data has been updated, and it gets refreshed automatically on the screen.
But for example, in this application you have here, if you had a second user accessing this and they updated one of the files, with the other and the other user was viewing that file,
there wouldn't be any change, because now I create this text file property object in the application. So there is one text file property per application, and we don't put any hooks to the file system for kind of listening changes.
That file system wrapper object that you created, almost first thing, doesn't, it's not?
No, it's not listening to the changes on the file system. Any other questions? Okay, thank you.